Record. Hey, yeah, welcome to Coffee Compiler Club. Here today to talk about like compilers and language runtimes and typing systems and whether you love or hate templates or null or anything and everything. To do with compilers, you're all being recorded live. You'll show up on YouTube within a few hours, probably. I normally don't have a set agenda. Today I have a little bit of a set agenda. And so I'm just gonna done with my spiel. We'll do an original initial Q&A, and then I was going to demo simple. On the Discord channel, we had a big discussion about how does simple collapse, or how does the sea of nodes collapse a particular set of a particular program, and how does this work? And so I was going to demo how that works. Also, we have a new person, Zalim. Can you give yourselves like a 30 seconds or less, like who you are and why you're here?
Do you hear me?
Yeah,
Right?
yeah.
Okay. Thank you for having me here. I'm Zalim. I'm working on Kotlin at JetBrains for quite a while. I think 12 years this year did we. Now I'm working on Kotlin wasm toolchain. Yeah, basically all this time I mostly worked on Kotlin compiler things. Now I'm working Kotlin in WebAssembly.
Cool.
Yeah, that's it.
Yeah, great.
So if you have any question about Kotlin or WebAssembly, maybe together, maybe each other. Yeah.
There you go. So yeah, I had a conversation with Ben Titzler recently, and he was talking about his experiences with Sea of Nodes, and his experiences and mine are very different. And we exchanged some emails, and he may come on here in a few weeks and talk about what his experience was. And he had some specific issues that he had troubles with that I had reasonably quick, good answers for. So there may have been an opportunity lost for doing something different with V8. And I don't know what the state of WebAssembly is now, so don't go there, but there may be a chance to do something there with WebAssembly too. I don't know.
Yeah, there's a lot of works around WebAssembly. Yeah, I know.
I have a question.
Originally, it was built for web things, but nowadays there's usages outside of browsers as well. There's standalone virtual machines targeting only WebAssembly without any JavaScript support. Yeah, they doing great. One thing what nice about standalone WebAssembly times is what they lightweight in terms of size, and also they able to run new WebAssembly models in microseconds.
Yeah. No. I think we're aware of what the call for WebAssembly is, or why it's out there.
I have a question.
Yeah.
What WebAssembly target are you using? Like, are you doing binarian at all? And if so, like what WebAssembly features do you need? Are you doing like garbage collection types, like struct.new reference types, or are you doing like a because Kotlin requires a garbage collector, right? So how are you like handling that in WebAssembly if you can't inspect the stack? Are you doing like the native garbage collection or anything with like that, or reference types, or
Wait,
how
let
much
me answer.
WebAssembly? Sorry.
Cliff wanted to say about that something?
No, I wanted you to say.
Okay, yeah, I can. Yeah, definitely. We use garbage collection proposal what released last October, I think. And the decision we decided to do that because first reason is performance, because on top of core WebAssembly without special GC support, it's difficult to implement performant garbage collector, because you don't have access to stack, for example, directly. So you need to implement shadow stack. You need to support it on runtime, and it costs. So yeah,
Zelim, do you have a link to the GC, the GC proposal? I know several
yeah,
floated around WebAssembly. Yeah, put it
yeah.
into the
I
chat.
can drop it.
or in your doc?
So wait me a second.
Yeah,
I got
there
to
you go.
drop the
Got
link
it.
to it.
Yeah. Somebody move
Yeah,
that in.
that's right one. Yeah.
Yeah, cool.
So yeah, current Kotlin wasm depends on GC proposal, and another proposal is exception handling proposal. There is a proposal helping to with stack unweighting and things you need to work when you use something related to exceptions. There's funny things with naming is hard, and GC proposals say only one sentence about GC itself, but it's more likely about primitives, what helps to make memory management. GC proposal introduces
Yeah.
structs, additional types,
Okay,
reference
wait.
types.
Yeah, you
Yep.
don't have to read out what it's in the GC because we can all read. So
Yeah, the thing about the GC proposal is that you need to implement a GC in the WebAssembly runtime from like when you have the GC proposal, you need a GC in your WebAssembly runtime. And I have been implementing a WebAssembly runtime over the past couple of years, and it's been like, hey, there are these new features, and it just gets increasingly difficult to implement. So like I don't really have any comments about the Kotlin at this point. I'm just like, GC proposal, because it's actually quite difficult to implement a good
okay,
GC for
you're bitching about the
WebAssembly.
GC proposal.
Yes, correct.
Actually, GC proposal itself don't force you to have any kind of GC. It's you can have any way to manage memory automatically. It could be something like reference counting with additional support for cycles, but even more, you can have a simple one what just allocate things. In some cases, it could work well when you just want to run your wasm model, do something, and drop it. You even don't need to super powerful garbage collector.
So back up. So
Yeah.
Shaw, why do you think you have to have a GC, or is this
You
just
have to have a
common?
GC or alternative like reference counting with cycles to
Okay.
implement the GC proposal. Like you have to do some sort of automatic memory management. Whereas before, all you had to do was manage a big array that the user literally tells you to grow. That the WebAssembly module literally just tells you, hey, I want to grow the array now. Now you have things like, hey, yeah, this thing is external to the module. Like it's on the WebAssembly stack, but you can't find it in memory. And it makes the runtime significantly more complicated because I'm doing a interpreter for WebAssembly, like a baseline interpreter, and then later trying to make it super fast. And it is quite fast, but like GC just makes it
Yeah.
have to add an extra detail. I had to do some
So aren't
magic,
you
and
using Yasser's backend stuff?
no, this is a different project than that. This isn't my Lua runtime. This is my WebAssembly runtime. It's
I see.
Web49. I will get
Okay.
you a link.
Yeah, throw it in the chat there.
Yeah.
Or in the doc or whatever, yeah.
Yeah, I'll throw it in chat because the doc never works for me. Sorry.
Oh, is the doc not working? Is it like
No,
other
it's just
people?
my Google account. Google doesn't like me on my browser because FreeBSD reasons.
Oh God. This is like, you should be able to bring it up in like Firefox and just hack.
I'd love to, but
Oh, you still have to sign in though. I bet you have to sign in.
Do you
it's
mean
like there's like a random DRM thing going on, and
Yeah.
I don't trust like it on my anything else.
Fine.
Yeah, that mini VM is my Lua runtime. Web49 is the WebAssembly interpreter.
Yeah.
Yeah.
okay? Yeah. I solve it.
Yeah. So Lebo's saying he's not signed in and he can type and he's on Linux. So he's wondering if you could get there anyhow, but don't worry about it.
Maybe I'll try again.
Any more WebAssembly questions here? We got another expert in house. So I was going to go do Levo's question for doing simple things, but I want to see if there's anyone else wants to bring up something before I head that way. All right, I'm doing it. And I will attempt to bring up, share, if I can find, I opened up too many windows and pushed them all to the back. Yes. Okay. Share, we're going to try it this way. And I have something that I'm attempting to make YouTube friendly by restricting the size to something that looks like it fits on YouTube. I have no idea. Okay. And then I'm going to, oh, here's Derek. And I will hide this. No, more, yes. Hide floating meaning controls. Okay, great. Hey, Derek. So for Levo's sake, and for other people who are curious, here is a program written in simple, not in C++, Levo, but it does your thing. So the program starts by making a bunch of junk values that aren't changed elsewhere, but are sort of opaque to the optimizer, where arg is an initial value. And then there's some test, which is opaque to the optimizer. Then there's this math, and then there's some other math. And you see the maths look very similar, but they're not perfect. And then at the bottom, we're going to add G and H. Well, that's going to look like one of the P's that are coming from the merge, and then subtract. And here, simple is going to decide that it's actually a 0, throw the whole program away, and return you a 0. And that's what the assert down here is saying. Hey, the program says return 0. Is you good with this now? People, I don't have anyone's screen going. I can't see people. And yeah, Levo. Well, okay. So Levo this is the thing here. So I'm just going to run it. I have some breakpoints set. I'll come around to again. I'll just go to the end. Die. Yeah, fine. Okay. So here is the return 0 on the stop node. At this point, I have something in the console window, and in theory, I get this right. I can do this, and here's the output of simple. So a couple things, like ignore the tiny font on the left. The graph on the right is the graph that gets left over. So it ate up the body of the if. It left a junk region if test that should be optimized, and it's not. And it did get a 0 in the end. So it does decide that the program has a 0. That is, you add 2 opaque things for X and Y, and you add 2 opaque things here for A and B, and they're not really related to each other. But then you copy G and H for X and Y, and G and H for A and B. So when you get down to the bottom here and you add G and H, you're effectively adding P post the merge, and you have P added pre the merge. So after the merge, P is the merge of 2 adds of random things. R is the merge of 2 adds of random things, and so they're equal. Okay, so I want to I want to demonstrate adding a new peep and getting rid of the dead guy. I want to show how it got there. And so I'm going to do that by rolling through the program. And so people, does anyone care which order I do these things? I can show the people and get rid of the dead test. It's a very simple thing. Or I can go show you where the collapse handed that Levo was so excited about. And it's one of the people optimizations that does a stupidly easy thing and will trigger the collapse. No one cares.
So let's roll out.
Sorry?
Let's roll out. Let's to see.
Let's just go do something. Okay, so I'm going to do the throw. I'm going to kill the region. I wrote the code in 5 minutes and then commented out so it would not, so it wouldn't do it. And then I'm going to add it back in, and I'll explain what it's doing. It's a peephole rule. The peephole rule is buried inside of region node idealize. So what Idealize does is it just tries to do a local people. So he inspects a region of the graph and makes a change based on the region. And the inspection is, I have no fees, so I'm a dead merge point. And my two inputs, I have two inputs, and the two inputs point backwards to the same if. So I have a left input and a right input, and they're control projections. Those two control progressions agree that they point to the same if, and in fact, it's an if. If that's the case, I'm going to replace the region with the control for the if, and that will make everything else dead code eliminate. So let me go pull the graph up here. So from the region, I look to the left and find a control projection. I look to the right, find a control projection. These two projections, oops, oh wow, no, I can't select here. How about, no, I can't select. So the false and the true point to the same if. And if that's the case, I'm going to replace the region. Yeah, I can't select it with the control on the if, which is the red arrow pointing up to dollar control. When I do that, the region will go dead, and dead code elimination will just say, I have no users, I delete, I recursively delete false, true, if in the test. So that's what's going to happen there. So we'll go back here. We're gonna break ourselves when we get to the test. We're also, well, when we get there, we'll do the roll up here. So here's some prior stuff that didn't happen. I'll come around to it in a minute here. So a bunch of times I'm hitting the return null because the region's looked at a few times, but he has users. So if I come up here to look at the region, he has some outputs. The outputs have fees. It fails the has fee test. So I'm just going to skip for a while here. Hit iterate top of the world. Okay, so I finally made it around to the region. He has one output to return. He has an input 1, which is a projection, whose input number 1 is an if. And that if is actually node ID 24. And his input number 2 is the same thing, has an input. It's also an if. It's also the same node, it's the same if. And that's the trigger point. He's just going to return control here. So rolling uphill, I'm in the people optimizer. Peephole optimizer, he says, I didn't idealize. I made some progress. In is not null. So it wasn't the region but it's now the control projection. So this is a peephole fired, and I now want to replace in the graph. So I'm in the generalized work list. He says, I got something. I didn't report a dead thing back. I'm going to set you types. I'm going to see if you're a constant. I'm going to do a bunch of work on you. I'm going to replace you in graph, but I'm going to skip that part and go down to where I start getting the kills. So there's a graph rewrite rule going on, and I'm going to roll down here and say, the region went dead. It has no users because I swapped it out for this input control. So the output size is 0. So he's dead, and so I kill it. Recursively, it makes the projection true go dead. Recursively, false goes dead. Since they're both dead, the if goes dead. Since it's dead, the divide of arg by 13 goes dead, and the constant 13 goes dead, and arg's not dead. But the constant, oh, maybe arg is dead. No, arg's dead too. So arg goes away as well. There's a second pass to make sure I got it all, and I'm done. And if I now look at my program, let me clear and go show graph. And I didn't do it because I had it already. See if I get show graph here. Oh, crap. I had it and I did it. There's the live demos for you. Come back around, get rid of kills and breakpoints. Just get me back to show graph. This is the correct one. I did too many things here. Practice this a little bit. And then here's the remaining program. So that's what that peephole did there, which doesn't answer Levo's original question, but it shows that we can, in fact, do simple control cleanups with a simple peephole. Okay, so now I want to go back through and ask the question, how did this thing happen? And to do that, we're going to roll through the parser, and this transform here is the key one that Levo is probably more excited about, but I'm going to start by finding places where things happen that look like optimizations, and then we'll talk about where that optimization happened and why. So in people optimizer, up at a breakpoint, if you make a constant, If I hit in the value numbering table, global value numbering gets a get. If it's not a null, you're down in here, you got a hit. If you're in idealize and you made a change, if you kill somebody, the kill got a breakpoint already, I'm pretty sure. Yeah, so we'll just go run the thing. Okay, so I ran the thing, and immediately, pretty quick here, I got a 0 in the global value numbering table from a 0. So that said I had a 0, this is node 15. I found a new 0, node 4, I found an old 0, 14, what was going on? So the parser says I'm parsing a block. You roll up the parser state up here, and the view is the remaining unparsed program, int h semicolon. So I'm going to look at this. That's here. That's unparsed. So I've parsed p, and the variable p will be assigned a 0. So I'll make a 0 to put into p. Then I'll parse g, and I'll make a 0 to put into g. Well, that's the second 0. Well, the second 0 will value number to the first 0. So let's go look down here. I'm in the parser. I parsed a statement. I parsed a block. I see an int. That's a parse declaration. I'm going to parse declaration. I looked for an expression. I found a semicolon. So I'm looking for expression. I'll see an equals an expression that's an initializer, but I didn't. So I do make the initial value a constant. Integers initialized with 0. I'm making a 0. This is the second 0 I've made because I made one for h. Now I'm making one for g. They value number. Fine. So since they value number, I'm going to dead code the one I just made. So I'll go back up here to parse decal. I said new constant node. This optimizer says dead code eliminate that guy and return the old one. So he gets into kill, and then I'm done. Oops, sorry. And then I went forward too fast, which is fine. And again, on parse decal for h, same story, same. Another 0 goes away. Okay, here's another 0. Where's this one come from? Well, parser block, parsing an if, parsing the expression for the if. I'll set a breakpoint here. Parse expression, then I'll find a semicolon. So middle of parsing an expression was a compare of a multiply of a unary, primary, blah, blah, blah number. Where did this number come from? Well, it's this 0. So I found a third 0, or a fourth 0. So I'm going to constant fold it. Fine. And there's the 0 I'm deleting, and I'm back. And I hit an idealize. So something happened in idealize. The original node I started with says compare arg over 13 equals 0. The new test is bang, arg over 13. It's not arg over 13. So I'm replacing, while I'm parsing, now I'm going to go to my control stack. I'm backing out of the parser, or out of the people, to the parser. I'm middle of doing this parse expression. This parse expression in the parser. So I'm starting in the if expression. So I'm still parsing an if. I'm parsing an if, and I got a 0, and I'm replacing, an equals a 0 expression, replacing that with, a bang. Okay, fine, I do. Which means I'm going to delete the old bool equals and return the peephole version of the bang arg. So I'm going to peephole bang arg. He says, I did something, I did nothing interesting in it. I added a type. I didn't change the actual thing. So I'm going to make another go. Now I get nothing exciting. So I'm out of here. I'm deleting the old guy and returning the new guy, and I'm out. Oh, here's the delete of the old guy. We unwind. The equals is dead. Unwind again. Oh, there it goes. Okay, so I completed the bang on the expression. This is the end of the excitement. If I look up here in the parser, I see I'm looking for an open paren as the next. Oops, this window will not show. Can I view it and make it appear? Maybe. Hey, that probably shows up on your video. All right, I'm looking for an open paren, a closed paren to end this expression. I'm not going to find it in this parse comparison because he's just looking for compares. So he breaks out and says nothing. The require says I need a closed paren. He gets it. He's done. He's made his predicate. The predicate is bang arg over 13. So then I'm going to go look at the if, and this is going to do an interestingly weird thing, which is not quite yet related to what Levo was originally looking for, but it shows something is going on. Oh, he didn't do it instantly. Oh, he wouldn't do it instantly. He would do it here. So we're making if true on an if. So the if node says if bang arg 13. if inputs are control projection to the start and not of div of blah, 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 blah. Run. I get an idealize that this pointer, the original I started with, is a projection true. Going back up to the if, I said make a new true projection and then peephole it. What's the peephole doing? It says I made a false projection whose input is an if node where the bang is removed. So he's decided that if I'm saying take the true arm of an if with a negate or a not, instead you should take the false arm without the not. So he's optimizing the if control expression directly before he's even finished with the original if expression, because the parser still has a hook to the original if expression here, if node, because he's going to use it again in a second. So this banged if node is going to get used, and he's made a new version of if without the bang. So I'm going to run on from there, and he's going to do some stuff. Here he's killing the old true projection he made because he's got a false. And he's back over here for the make the false side of the old if, run it. Okay, he did something, and he says, oh, I'm going to have a new if, and I global value numbering it. I made another new if. Well, where did that come from? Going up for the peephole, I peepholed something from idealize. Here I am in projection node. This peephole rule says if I'm an if projection and my predicate on the if is a not, then I should reverse, return a projection where I make a new if, which is the same control as the old if, but instead of the test being a not, it's the not's input 1. So I take the unnegated version. Also, I renumber my projections to say false or true or false. So I flip the projection here. So I have found in the global value numbering table an if test, a control flow piece. So the global value numbering includes control flow. Having found it and replacing it, here I am busy killing the new if I just made because I found an old one. And then I'm reporting back success on replacing the original false with a new true of the negated test. So I'm going to kill the original false. Then I'm going to kill the test the original test with a negate on it. And I finally came out of the test here back to the parser's if statement. And I see that the if from the parser's point of view, the original if is actually dead. The predicate will be dead, except the parser has demanded I keep a copy of it because he's going to use it in a minute, but it'll be dead in a minute. And then I'm going to go on and do true and false sides of things. So at this point, I'm going to stop and show the graph and then see if anyone wants to ask questions about what happened here, because we're getting closer to where Levo's other question came from. So here's the current graph. At the bottom, I have a bunch of mappings, and they are nested because I have whatever scope's going on. So scope level 0, scope level 1, P, A, B, G, X, H, Y, what the hell, 1,000 things here. Okay, well, so a bunch of these things like P here and G and H are all defined without any value set. So they'll just point at 0. And A, B, X, and Y all are some variation of add, subtract, multiply, divide against the original arg to obfuscate things for the optimizer. And the parser is hanging on to the bang node just to the right of the if, but I have an if true and if false. There's false and true are now backwards because I flipped them internally. Is that so? I'll stop here and ask, does that make sense to people? Oh, here's where I can't see faces because of this. Oh, I can see faces now.
Yeah.
All obvious. This is like particularly for Levo. You understand so far what's going on here?
Well, my 3 questions are, what's the /? What's the multiply? Because the original source code didn't have divides or multiply. And also, who generated this? Because that's a pretty nice graph.
Okay, so first question, the / is integer divide as printed in the graph. If I go look at the code that I wrote, here's a divide. arg divided by 3.
Oh, right. I forgot about that because that wasn't in the original Discord code.
Well, that was it something similar to it was. The goal was they were passed in as A, B, X, and Y that were unknown to the optimizer. So I made,
right.
and because simple doesn't have argument passing or anything, it's too simple. I made obfuscated things. So the optimizer is not doing anything with these expressions.
Okay, I'm following you again. Yeah.
Okay. Back to the graph. This is done with dot. Graph viz. So graph viz is a wrapper over dot. On the left-hand side, I am auto-generating this code on the left. And simple has a thing you can see, just walks the graph and spits out things that fit. And thank you for the nice graph, but we worked hard to make this graph nice. And it generally does a good job, but dot does the heavy lifting, but we spend a long time colorizing and pretty printing and forcing layouts and shit to get it to look good.
Good job.
And what was your other question? You had 3.
Yeah, no, that was it. The divides, the multiplies, because I didn't remember that.
Yeah, okay.
Code, and then if you actually
So-
generated this multiply.
Can you return to the code, to the source code in the string? So the main two things here is the eliminating of the if block stems from the fact that the P and G are instantiated because they're primitive to 0, as I got it, or no?
These are all initialized to 0.
Okay.
But I'm going to write them. I haven't done it yet. I'm going to replace them with these values.
And there is some inversion of the condition because it's.
I effectively replaced this. I effectively negated that test, and I'm going to swap the true false sides during parsing. That swap has already happened.
Okay, that's beneficial because
it gets rid of a node in the graph. It was direct reduction in nodes in the graph. So all the p-poles have an implicit profit. The most common implicit profit rule is fewer nodes in graph.
So how the negation decided that it will get rid of rid of the
okay, so let's see here. So
because there are a lot of subtle things that are happening here. So
probably down here somewhere. If true, where did I do? Oh, it's in projection. Oh, geez. Yeah, here it is. Okay, this was the test. So this test says, I am a projection. I point to an if. The if points to a not. I can rewrite myself without the not. So this test removes one node in the graph. The rewrite replaces myself with an inverted version and the if with an inverted version. So I didn't actually do a 3 to 2 yet. I'm taking 3, a control, if not, to a 2, a control and an if, because there's a second projection also at this if to the same not. But he'll take the same inversion test and he'll end up with the inverted guy and an if. So I actually have 4. I have 2 controls, an if and a not. I'm going to end up with 2 controls and an if. So I went from 4 to 3 here. So it takes a couple go rounds to get there.
Okay, the decision here is hard coded to if can do it, do it.
Yes, because it is locally profitable. So all these p-poles, the whole point of them is they are locally profitable. And in the end, I typically get really good optimization out from a series of locally profitable transformations. There is room in places
locally
and times
profitable and monotonic.
I'm sorry. Well, that's the profit. It has to be monotonic. And the monotonicity here is I went from 4 to 3 nodes. I can't repeat that indefinitely or I run out of nodes, right? And basically I'm going to do that. I'm going to run out of nodes. Many of the profit rules are more shortly obvious. So let's go look at add here. Here's an add. This one says my right-hand side is an integer whose value is 0. I'm add of 0. I'm just going to return the left-hand side. So it's immediate reduction of add and 0, go away. So left add 0 went from 3 to 1. So just directly obvious. Here's one's a little less obvious. My left-hand side is an add, and my right-hand side is an add. I'm going to flip you to make a left spline tree of adds. So that is monotonic, but not reducing nodes. It's just shuffling the graph to get a left spline.
Because
then it pushes all the constants next to each other. So I have a complicated add tree that has 2 inputs, which have 2 adds, which have 2 inputs, 2 adds, and I have a big old expression, say it came from array addressing math. You get a lot of these.
Cool.
You have constants all floating around it. By putting it into a left spline format, all the constants line up on the right-hand side of the left spline, and they all become adjacent with another swap, which puts constants up or down, and then you can fold all the constants.
Cool. Yeah.
Yeah.
See,
So like
a lot of implicit stuff.
so what you're saying is like 1 plus x plus 2 would turn into x plus 1 plus 2, or
Which
x
1 plus 2
something.
folds. Right.
Then
and
it would
folds
then
away.
fold the okay,
Right.
yeah.
Right.
Okay.
So these are all rules that have some profitability that I can measure typically very locally. So
But
you
the
can
key,
see I have this one here is the comment above it, goal, a left spline set of adds. Here's one of my transforms. Here's another transform. Here's another one, but see the comment says, we might see add of a non-add or add of 2 non-adds or triple set of adds, but we never see add, non-add, add at this point. So I'm working toward that left spline. Then I do this kind of rotation. Oh, I have a triple set of adds. I'm going to shove them so it's a left spline format. Take the right add and the right-hand side add, move it to a left-hand side. So there's a rotation there. And then we see another comment that says, hey, now we might see add, non, or this or that, but never these other 2 forms. So now I'm going to do this rotation. And so on and so forth. And after a while, I get them all like lined up and then they all fold up.
So the key here are that you have all the information statically to take that decision. So
Right.
no more you're pushing it to, so you're arranging it that so in the end it will happen. The miracle will happen.
Yes. And this miracle is broadly applicable miracle. It's not just a one-off or targeted for this thing.
Yeah. And we are using the fact that it's the plus the arguments doesn't matter, so they can fold it. They can be pushed, so they can be folded.
Well, in my head, I'm taking advantage of the fact that the semantics of the program are exactly and only in the nodes and edges. There's no other semantics. So I can do things upon a local inspection. And in particular, I don't know what the future unparsed program does. There may be much stuff in the future unparsed program. I don't know. I don't care. I'll get the same answer in a minute anyhow.
So only do the most simple stuff that it is not likely, it is safe to do.
Yes. There are other things I do which have more global effect and have more larger scale and variance to prove monotonicity. These peoples are not that. These peoples are all local, correct, on the spot.
Okay.
And then Levo, you said something about arg over 13 not being 0. I can pass a 0 in for arg and it could be 0.
No, I meant that because Theodore was asking why is he wasn't asking directly why is there a not, but the problem was you're trying to remove the not, and the reason why you can remove the not is because you can implicitly assume that you can implicitly check if args divided by 13 is not 0.
I am
Like you don't need to compare after that. So the not is removing the compare.
That's not what I'm doing. This expression is completely opaque to me. I have no clue what this expression is, and I don't need to.
How did that expression create a not?
Because it said equals 0.
So
there's a 2-step process.
I think
this turned from what you see there to a version that was if.
So
opaque,
what?
Opaque.
How did?
And
I think I know what Levo's asking here, Cliff.
Okay.
So you can remove the not from an if expression if you just flip the branches around.
And then I flip the branches. So the third thing I do is I flip the branches around.
So that's all you need to if you're in an if statement and the test is not, then you can flip then and else around and remove the not. That's the rule.
Yes, but I thought I was answering Theodore's question by saying that instead of having the not as the compare, you would not have any comparison. It would just be implicit because you can check if something is not 0 implicitly.
Yes.
But
this
okay.
is what happens here in this third line, this third if. So the C of node semantic says an if takes a value which implicitly can be checked for null or not. It's what the hardware will do. So if it's integer null or a pointer is null, the hardware does not care a whit and cannot tell the difference and won't bother. So this is intended to be, you know, code generation for some targeted backend. So yes, I am implicitly doing a null check baked into the if test on every hardware on the planet.
Cool.
Okay. Is that, we good on that at the moment?
Yeah, we can roll.
Yep. Okay, I mean, let me, why are you not? Because something happened here. Oh, look at this. How about that? How about them apples? Yes, thank you. Where did I get to? I was here, somewhere. Okay, yeah, I'm the parse if. So somewhere in the parse if, I have finished flipping the if condition. I haven't parsed the left-hand side or the right-hand side yet. So I'm going to do that. And that's going to happen right down here. I'm going to roll through parse statement. And then I'll show the graph. And it's going to be pretty obvious what's going on here. So I'm going to look at the graph right now. So here I have P, A, B, G, X, H, Y, blah, blah, blah. Many of these things point at 0, but A and B point at divides and multiplies and other weird things. But I'm going to define P, G, and H when I do the true side of things right here. So I'm going to define P, G, and H, which if I go back to the graph, they're all pointing at 0. So here's H is easier to see. H is pointing directly at 0. But if you follow the little dashed lines, they're all tangled up in there. It's still pointing at 0. Okay, so go back over here, go back to the parse if. I'm just going to hit continue. I'm going to stop. Oh, something happened along the way. So somewhere in the world, I made an add of arg11 divide by times plus arg7 something. And the idealizer returned me the same node back, but what he did is he did that left spline manipulation. He rotated, he swapped edges. That'll happen again. I'll just set a breakpoint the next time swap happens here. We'll find that one again. So I did a swap, but the swap does nothing exciting further. So I'm going to re-peephole the swap. He's going to come through and just roll through and say the peephole's new, goes in the list. Try again, no change. Come back out. In is null, no change. I'm unwinding back to the first guy where I did the swap. That's also going to say no change. Come back out. I'm in the middle of doing math expressions here. So semicolon dash in the view. This is the remaining. Oh, geez, come on, die. No view. I have to find this tiny little edge. I go. The remaining unparsed program says find a semicolon, set G, whatever. So I'm setting P here. So I'm going to continue on. Okay, back to the parse if. I've done my thing. I'm going to look at the graph here. Okay. So now I have two different scope sections at the bottom. One is through the parsing of the true side, and one is the remaining false side hasn't happened yet. So here on the left-hand side, I see H now points to arg divided by 11. G points to arg times 7. So I have parsed G and H. And Lebo, you asked, why am I copying things? Well, right now I have two different mappings. There's a mapping on the left, and the mapping on the right is the one that says I haven't parsed the other side yet. I need to hang on to that mapping. I'm going to parse it in a second. So on the right, P, G, H all point at 0. On the left, they point at other things. So that's why I made that copy. Okay. Going to go back to here. I'm going to go parse the other side, and then we'll stop right before we merge the two sides. Oh, here's the swap again. So the swap's happening because I have arg divided by plus here, and there's some rule. What's the rule? The rule is saying I look for the spine computation rule, which if I find spine comp here, he has some rule that says like, hey, constant, oh, we're all constants, this, that, whatever, fine. Eventually he says, freaking just order by node ID. One of these rules triggered and he's ordering. Okay, so coming back, that's idealize is swapped. He's going to kill a 0 he found. Why did he kill 0? Well, let's go take a look. Somewhere in the world, he's looking at name H. He's about to update H. We'll look back at my graph. Here's H on the right-hand side pointing at 0. It turns out P, G, and H all point at 0. So when I do the false side and I assign P, the 0 now has 2 users, G and H. Then I assign G. Now the 0 has 1 user, H. Then I assign H. No more users of 0, it's dead. So going back to simple here, I have come through, I'm setting H, I'm doing the update logic, which finally bottoms out at set the edge to the multiply of arg by 5. Set def internally says, well, look at the old guys, the 0, he has no users, kill him. So I'm killing 0. I'm now right before the merge, so I'm going to go take a look at what I have the two merge sides now look like. Okay, so he's not showing the two scopes because the show graph is confused because I'm right before I'm merging. So the nodes are all present, but the mappings for the other side are not. But you can see somewhere in the world, I have a P pointing at an add of a multiply of a divide. There's another add in there of the other side of things. So I have 2 different adds that are live. And they'll have the appropriate mappings, which I can't see at the moment. So the excitement that you're looking for is coming up here when I do merge scopes. So I'm going to step into merge scopes and see what he does. So he puts a region node to say merging the left and the right of the if. Then he's going to walk the line of the 2 different scopes. And he's looking for where they change. So that would be the this scope and the that scope. And they have inputs of 9 and inputs of 9. There's small screen, big input counts, and they have lots of things. Starting at 1, I've already set 0 in, so I'm going to ignore 0. Starting at 1, I see a mapping for arg. And on the other guy, mapping for arg, it's the same mapping. Arg's not been touched in either the left or right-hand side. I don't need a phi here. So I'm going to say, if they're unequal, they're equal, so do nothing. Go again. Oh, I have a mapping for A, B, X, Y. All these are no mappings. Nothing happens. So I'm just going to skip them. There's a bunch. Okay, now I'm at something that's exciting here. I'm busy mapping one of these guys. Who's my I? Index number 6. It's this guy. This is P. I'm mapping P. I need a phi node for the mapping of P. So I'm going to step across. Oh, wait, I couldn't. What happened here? I went into the phi and I'm looking. Here is the original node I made. I made a phi merging an arg of 11 plus and an arg times 5 plus, whatever, 2 different garbage things. What the hell is a phi merging? Well, he's merging P on the left and P on the right. Go back to chapter 10 test here for a second. He's merging X plus Y and he's merging A plus B, where X is something and Y is something and A and B are something. It's a big pile of garbage, but he's merging 2 things. But this people rule says, I have a common op. I'm merging, one merge is merging 2 adds. If I pull the adds down through the phi down below, I have 1 less add in the world. So it's locally optimizing to say, I'm going to get rid of an add. Instead of adding on the left-hand side and adding on the right-hand side of the if, I'm going to add afterwards. Back to chapter 10, this code, instead of adding here, I'm going to put X and Y in some temps. Instead of adding here, I'm going to put A and B in some temps. I'm going to do an add down here and then merge the 2 temps and then add. So instead of a merge of 2 adds, it's 2 merges and then added. That's what's going on. And this is where the kind of confusing magic happens. So this is all setting up and building the 2 sides of things. I'm going to make 2 phis that are merging left and right. Temps are free in SSA form that costs literally nothing. So I'll just make 2 fees. Each one is going to do something. And now I have 2 fees. This fee is merging arg11 and arg5 as A and X. And this one is merging Y and B, or B and Y or something. And then I'm going to take my op and copy this and add. So generically, I'm going to return an add of things. Coming back up here, I made a change. I now have an add node who's got 2 fees as inputs. And can I do something with those? If I did something, let's go run people again on add of yada yada. Oh, I'm going to swap them because it's an add, it's commutative, I can swap. Okay, fine. Let me come back up here to merge scopes. Oh, I got a breakpoint set. Okay. And we're going to run again. So here's the add with swapped inputs. Oh, what am I doing here? Oh, I'm killing the original fee of an add because it's being replaced with an add of 2 fees. And now I have this add, and it's just, whoops. The add of the original guy went dead. So back over here, testing test. This add goes dead because I have a new add down here, not shown in the program text. That's the add of 2 fees. So this add goes dead. Also, this add's going to go dead. So we're going to carry on. Here I am finishing up the last guy, and I must have deleted the other add already, I'm hoping, and I'm making another fee. Now, this is a fee for merging A and B, or X and Y, or whatever, X and A. And B
I
and
got
C.
a quick question.
Yeah.
It sounds like moving the ads outside of the branch, so it's inside the fee.
Yeah.
That sounds like it would be more expensive and not like monotonically
Okay.
profitable.
So
that's what confused me before.
Okay.
It doesn't seem like it would be profitable.
So here's the trick. Fees add no code. There's 0 code in a fee. So I can freely make more fees. But I got rid of 2 adds and put 1. Now on all paths, only 1 add ever executes. So I'm only ever executing 1 add here in either way, but I've reduced my code size.
I see, yeah.
Okay. All right. I'm busy defining the fees I've thrown down and discovering, oh yeah, this is where the next piece of excitement happens. Having made an add of 2 fees, the left-hand side fee for arg times 7 arg over 3 matches the one I just made of arg times 7 arg over 3. So going back here to the code, here X is arg times 7. And I'm adding it down here to this A, which is arg over 3. Now G, who's merging X and A, is exactly the same fee. So the one I generated by putting the add down exactly matches the add of the merge of G. So the GVN has found via common sub-expression relation via the hash table that I've gotten the same fee. I've just found another version of it. So I'm just replacing it. So already I'm starting to clean up because the G that I'm finding post-merge matches half of the add I just made post-merge. Going again, I'm going to kill the fee I just made because I've got one already. I don't need a second one. Doing now H and H on both sides. I make a fee, I find another copy, I'm going to remove it. And then I get to remove the scope because I'm in the merge scopes here, and that's the end of my fees. I'm at that.kill down here, and I'm killing the scope. So that says I had these 2 scopes. After I merge them all, I keep one to carry forward and I throw the other away. So it's dead, I kill it. His inputs go dead, they get killed. So that means that the add that was kept alive only for the scope of the 2 sides went dead and gets killed. And I'm down here, haven't quite got the region done. I think this doesn't do anything exciting. Yes, I'm going to set my control. I'm parsing my if, done with the statement, time for a show graph. Okay, here I am, just post all that work. I see that P is an add of two fees called PP, because my naming is stupid on fees and they try hard, but they don't get it right every time. And he does whatever he does. And A, B, X, and Y are all unchanged, point to the original math. But the merge of G and the merge of H points to these fees. So I have an add of fee left and fee right, and G is the left fee and H is the right fee. So I'm already lined up for the next step that's coming, where I'm going to make R be exactly P. And then when I subtract the two, it'll just go to 0. Is that any questions on that one, or I'll move on here? Okay, good night, Shaw. Yeah. Okay, so we're going to parse a statement here. Do it. Okay, what happened? I step forward. What I got here is I'm going to walk my stack trace. I was doing a statement parse, doing a declaration of the name is R is equal to some expression. The expression says that's a comparison, which is some add of some people of something of left-hand side of a fee. So I added a fee of two left and right, and the two things is a fee of add of whatever. Going to people says, oh, I have one of these. This is value numbering hit again. I already have this fee. So R is equal to the fee I already have for P. So I'm going to, oops, you do go. Yes, thank you. So I'm going to kill the new add I just made. I don't need it. I have one of those already. And that says that's the end of that guy, and I'm on to the next one. Okay, the next one is the subtract, who's going to do the same thing. So I'll show graph that just so you can see what happened there, but it's pretty clear. Why are you being obnoxious? How about here? Okay, so P maps to this add, but R also maps to the same add. So P and R map to the same thing. And then in the original program, we're subtracting them. So R is now identical to P and known that way to the parser, optimizer, whatever. And then I'm subtracting two equal things. And that's a known 0. So go back over here, people optimize. The original guy is a subtract of the same things. So he's just returning a 0. And so he then kills the subtract he just made, which gets to kill an add he made earlier, and then the fee that he didn't need because they're all equal. Things are just unwinding here. Oh, that's because I'm here. How I should have breakpointed here. Damn it. I'm out of the end. I continued and I went to the end of the scope. The scope's going away. The block's going away. Scope goes away. He's busy deleting everything. So I'll stop breakpoint here. So at this point, all those scopes are keeping alive things. This scope is keeping a lot of this shit alive. This scope's going away. So a lot of things that are currently live are going to be dead very shortly. And so as the scope goes away, he's just killing things and killing things and killing things. And that's because pop in here is saying walk the scope and delete all your edges. So he's busy deleting his edges. Remove last. Is something there? Delete it. Oh, it actually went to 0. Kill it. Recursively kill. Kill, 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 mul 9, constant 5, divide by 3, the 3 dies. Finally got done with all that. I'm going to pop the parser here. That's going to do a little bit more deletion. I'll just run to here. Oh, we get to kill dead control, and we got to here. Okay, so let's go look at show graph. There it is. So he's cleaned everything up, except there's some dead stuff in the dead test, and the region hasn't happened yet. And that's going to wait until we get out of the parser. And we'll do the people work list. And that happens here. I'm in iterate, peeps that iterate. I'm going to walk the graph, sorry, the list of the work list. So over here, I have a work list somewhere in the world. You can go away, static members, I have a work list. Work list has 25 members. Here they are. Most are dead, but somewhere in the middle of here, there's that region that wants that optimization to happen. And the other knot is in here as well that will get cleaned up at this point. So I'm going to run this guy. Oh, he's finding something to kill here. What did he find to kill? He found the not node, which is in the graph. If I go back to the graph, this not right here was on the work list. He says, it's dead, get rid of it. So that's in there. Here's the kill on it. Here's some other scope, leftover scope being killed. I think I have a region. I set a breakpoint in my region here or not? I did. Okay, so we haven't hit it yet. Killing this. Oh, here's the region. I finally got around to the region. And here's my test in the region that says, you know, go back to here. This region has false and a true, no fees merging. So I don't care what it is. It's just a dead control flow diamond, has no tests. I mean, has no value, has no use. So I'm deleting the region. So when I delete the region by just saying the region gets subsumed by the ifs control. So there's the region saying then the current was a region, the new is this control value, this, that's the type, is this node dollar control, which is the start control. So just replacing the region in place, which meant that I found the region is dead. I'm going to get rid of this. We'll just find this and kill here. Here's the region getting dead. It's because it's dead. The true projection's dead now. Oh, the false projection's dead. Since they're both dead, the if's dead. Oh, since the if's dead, the divided by 13's dead. 13's also dead. The original arg to the whole program is dead. I don't need an argument as program. And ours returns a 0. I don't care what your argument is. Oh, I have another hook to catch it, but I don't need this one anymore. And we're going to try to kill a dead thing. It just doesn't do anything. And then we're done. And that's it. If I look at this guy one more time here. Oh, I did. I had it already and I blew it away because I don't have a parser to go ask for it. I have to do it this way. Boom, get rid of all these, just run to completion guy and give me the output at the end. This is like, get rid of all breakpoints. Way too many breakpoints. Breakpoints, breakpoints. No, no, go away, go away. Yes, close. I don't care. Done. Now I have this console. Here we go. Boom. And that's the final program.
I'm surprised how little logic you needed to deal with the fees.
Yeah, that's the that's part of CM nodes. There's little logic for almost everything. There's not a lot.
Wow.
Well, that was cool.
Good.
Yeah, I like it.
Yeah, it's kind of fun when you get it sorted
So,
out and it hangs
question
together.
pops to mind first. The scope of optimizations are only a few lines to a handful of lines, which is why
Yeah.
you're only looking part of the program to make the decision. How would you say, how large is the medium scope of optimizations? How lines would you say to span? It's roughly.
So add has the most of these peeps. Most of them are one line to pattern match and one line to replace, not all of them. So feecon here says, do I have a fee of all constants? And then do something because I do. So go down here to feecon and he says, oh, here's a bunch of code and it's 40 lines long or something. It says I have a left and a right of some op and do I get to rotate as peecon?
Let me clarify how the scope of the source program. So these example,
yes. This is what this scope's about. In here, I will poke my way 1, 2, or 3 nodes afar. So when I came through here at a feecon, where's an uglier feecon here? I know it shows up a few places. So at this feecon, how about this one? Yeah, both these feecons are saying something about true rotate or not. I thought I had one that had a different, oh, he probably recursively does it. That's what happens. So I called this feecon with a this pointer, and I've looked at one input away, op.in of 1 or 2. And then I called myself on the left-hand side. So from some guy, I went one hop. From him, I'm now recursively looking at these two. I don't go again because I have a cutout in here for that. That's part of the rotate thing. And I might look at one more input remove, left-hand side at N1. Or I might look at some other things on the left-hand side of this scope, but they're not going any deeper. And then down here is the rewrite. So this is looking afar. So this guy went 1, 2, 3, or 0, 1, 2. It's not too far. If I look at other things, they're mostly shorter than that. In 1 and in 2 mean I went 1 to the left and 1 to the right. In 2 to minus, he went to minus in 1 on the replacement rule, not on the pattern. So the pattern really went 1 step, the replacement went 2. Go to phi. Oh, I know where to find a bigger one here. I'll find you a big one in a second. I look at region, that's 1 step removed. I've got single unique input, that is 1 sweep across, it's 1 step. It's 2 steps, it's 1 to the region. Check all the region inputs, 2 steps. Here I have my left-hand side, and I look 1 step off the left-hand side, so 1, 2. And then I do the add rotation guy. Here is me pulling a cast down. Here's me going an immediate dominator test. So the immediate dominator test walks, can walk an arbitrary distance. And that's this while loop right here. That says, I found a checked value. I have a phi. I have a left-hand side. I have a right-hand side was a cast from a projection of an if. So I'm, 1, 2, 3 of the same left-hand side. So I said, I have an if test. I null pointer checked you. On the true side, I said you're not null. On the false side, I said you are null. Then I merged the control flow back together again. I got a phi. The thing I have at the phi is back to being an unknown pointer, unknown null or not null pointer, but it had a cast in the middle. And I want to get rid of the cast in the middle and go back to the original pointer because I know no more than I did before. So I start with a pointer, I ask the question, I put a cast on it. The new value for the pointer is the casted value, which says it's not null. I don't know what the pointer is, except I know it's not null. Then I folded my if test back together. I forgot that I tested for null. Now I have a phi at that merge point, and I'm merging the original pointer and the not null pointer, and it looks like garbage in the graph. But it's just the same pointer, so this test removes it. Now the one trick is the if doesn't have to be local. I have a phi, is some control flow, goes arbitrary, has some phi, has some control flow, goes arbitrary. There's an if way up here, and in between there's a whole lot of ifs and controls and all kind of shit in the middle. I don't know, it's a lot of stuff. But it's the same pointer. So I want to get rid of it. So I have to look not 1 step, but until I hit the immediate dominator of the left and the right side. So I'm looking for the 2 paths on the left and right side to find a meet point in the middle. And that uses immediate dominators. So at this point, I can go arbitrary far. In practice, of course, you rarely go very far at all. You go short distance. This also requires immediate dominators, which I can compute cheaply and lazily on a program with structured control flow. Java does not have structured control flow. They claim they do, but the JVM bytecodes do not. You have to run a full loop finder on Java bytecodes. Here, because Simple really does have structured control flow, I can find it all in linear time, the size of the program graph, with essentially 0 cost. It's like nanoseconds. It's unbelievably fast. I do a couple loads for everything, and I cache all the results. And the end thing is, nanoseconds times size of program gives me immediate dominators. It's super cheap. And then it lets me do things like this. So the same immediate dominator check happens in a couple places where I want to do far removed knowledge tests. So that's sort of this scale.
Yeah.
Constant propagation things come in 2 flavors. They come in the one I do in the middle of this where I look for constants. That one uses the lattice theory to let me do localized lifting of things. And if they lift up to a constant, I replace them with a constant and get rid of the program graph, and life goes on. There's the optimistic version, which comes down. That one you have to visit the whole program, and you have to define the graph, and the graph theory has to be correct, and your transfer functions have to be monotonic, and blah, blah, blah. There's a bunch of things. It's linear in the size of the program times the depth of your lattice. Again, it's really quick, but it's a whole program thing. And it will then find constants that you can't find any other way. Now, when I say constants, I mean constant values like ints, constant pointers, constant control, and that will be like dead things that are only dead if you do this algorithm and are not obviously dead otherwise. So it can do, it can remove big chunks of graph. It can really clean up.
Cool,
So
cool, cool.
those aren't peepholes. That one's not a peephole. I don't consider it a peephole. I consider it a phase. I'll run a phase for that guy.
Yeah. Whew.
Yeah.
So there you have it, folks. CF knows to represent program semantics.
Yeah, and where I got the cleanup for that was Jules and Levo were like, well, can you do this one? How about this one? Like, yeah. And then they eventually got to Levo. Jules got to a place where it's like, no, you need to do something more clever yet again. But boom, done. Okay. Well, there you go. So question.
Any
answer.
questions? Yeah.
Yeah, see, any questions? Yeah. All right.
Silence.
Everyone's brains fried. We can all go home now.
No, it's really, I'm impressed about how you can represent that, and I'm kind of surprised about how much nodes are needed to do all the simple a few lines of source code to represent the program semantics and then optimize it.
The general kind of rule or feeling here is that you get some interesting expansion 2 to 5 to 1 for a single AST, what you consider an AST expression.
Yeah,
So
that was my original
Y.
question,
Yeah,
because it's kind of surprising how much nodes are needed to represent the program semantics, and how this compilation unit of JIT optimizations should span in the real source, in the original source code of or what we call an AST.
Yeah.
I'm a little surprised that you global value numbered the zeros, because instead of having a node, you could just say it's a constant and not have the pointer. But
oh yeah, yes. So simple is intended to be a tutorial. There are many things we didn't do to make it run faster that would make the code, in my opinion, only slightly more complicated to look at, not really. My co-partners on here like it's a pure enterprise Java style approach, almost pure enterprise Java approach. So the code's very stylistic. I would change things and get a much higher performance attack. Now, the case of adds of a constant zero, that's a really common constant. It shows up in a lot of places. I would totally cache that, and the parser would directly say, oh, you got a zero. Well, let me give you the cached zero instead of making a zero node and then value numbering it. Yeah, that is a lot of wasting time.
So it would still be a node. You would just cache it, because I thought you would just have it as a constant.
Yeah. Right now, it's cached in the global value numbering table, and I find the same cache node in the value numbering table every time. But I would just make it a compile time constant. Start of the parser, when he makes a new start node and start of the world, he'd make a new zero node and put it in the parser. And then when the subtract says, I'm subtracting left and right, and they are the same thing, and I'm going to return you a zero for that. Right here, type integer constant zero commute. No, not that one. This new constant zero, I would say instead parser dot zero node and not make a new node. Right?
I thought that it would be so cheap that you would just not need constants to be like. I thought you would just have copies, like many constants, instead of trying to reuse, because they're so. It seems to me they're very cheap.
They are, but the reason to reuse them is so you can get cascading optimizations. As soon as I get a zero out, that zero goes into the next calculation and folds up.
Actually, wouldn't it would probably be harder to do global value numbering if you don't cache it?
I'm sorry, global value numbering is exactly the caching.
No, I mean if you had a variable plus 5 and then another variable plus 5, but the constants are not cached, then it would probably be harder to do the.
Yeah, it's not harder; it would fail.
Yeah.
Exactly what you need is the leaves to all be equivalent so that the trees that build on the leaves, expression trees that build on the leaves are also now equivalent. These are all built bottom up.
Got it. Well, when you say bottom up, I'm thinking about the burrs and why you didn't like that.
You got an add plus 5. So the add is down the tree, up the tree. The add's the root. The leaf is a 5. Now I have an add plus a 5 and an add plus a 5. The adds are called in the trunk, and the 2 5s are leaves. Well, I need them to be folded up, and then the adds share the same 5, but the adds point at things over here. These have to be the same, so it's the same X. Then I have 2 nodes that are identical except at the trunk. They're an X and an X and a 5 and a 5, and the trunks are 2 adds, and now the hash table works and says, oh, you're the same thing. And then you throw one away and keep the other. So yeah, it's built up or built down, whatever direction you want to go there. And I did a lot of zeros. So that's the well, whatever, fine. The not the dead guy. The other dead guy. This parse expression statement. That's t dot making it. That's a 0 for integers. It's a null pointer for pointers. So I make a new constant of a null. I can just put it, get the 0. Yes.
What do you think are the trickiest things to represent in the sea of nodes in the program semantics?
Oh, well, it depends on what your goal is. Like, I've built this up. This is all algebraic math here. I built this up. This went pretty quick. Everyone understands add, subtract, multiply, divide. As soon as you add memory, things you need to think about the problem a little bit more and what it means to do memory. So once you've sorted out what it means to do memory, it's actually really simple again, but there's some subtlety to it. I didn't show loops. Loops are nothing special.
Right.
Memory brings a lot of issues that you have.
What it means to be a memory. So
sorry?
What it means to be a memory. So
what it means
I'm
to be a memory.
the question.
Yeah. Right. So like this dude. This dude here, this test struct says make a bar, make a foo struct. Here's a bar struct. Here's a foo struct.
Yeah.
Here's a foo, nullable foo. Make a new bar, set it, return bar.a. Okay, well, foo never gets used. Bar gets created, then you load out of it. What do you think the program graph should turn into? It should turn into like, I'm going to return you a 2 because I set bar to a to 1, then I set it to a 2, and I return you 2. And in fact, it says return 2. So we go do this guy. We're done with this. Let's go check the program graph that came out. Find it again. Okay, so something didn't clean up, but it got really close. So what happened here? Well, we stopped doing peepholes because we were doing other things with the game. So we should add this peephole in. So several things happen here. The return is going to return me a new state of memory. That's the blue lines for bars, A's and B's. Now, as long as I don't return you a pointer to a bar, they're actually dead. But I don't have a peephole for that. So the return thinks the state of all bar A fields are represented by this store node, the A.A equals. All bar B fields are represented. And then the return value is known to be a 2 because there's a black line up to the 2. It's hidden under the red line, but the loop out on the 2, that's the black line. So I know I'm returning you a 2, but I'm returning you memory. So I could have a peephole on return that says, if my return value is not a pointer, I'm going to claim all memory state is dead. And then he would throw away the allocation of the new bar and just hand me back the 2.
So they're porting the same way. At some point, the .a can be exactly replaced with the constant. So
yeah, I've already replaced the A equals with the 2 on the return. So the return knows I'm returning a 2. He doesn't say I'm returning the load of an A. I'm returning a 2.
Okay.
But he's also returning the state of memory. But in large real programs, you always return the state of memory. And so, that optimization says, It's locally dead right here is kind of, it's not slimy, I guess. It's legit, but it's pretty weak. I've made an object and it's locally dead. And I can tell that it's locally dead in very trivial cases. As soon as you get slightly more complicated, more realistic, it's never locally dead and you don't actually get anything out of trying to do this. I'm not really doing escape analysis here in any great way. I'm doing a very crude, very bulk escape analysis by saying the return value is not a pointer, therefore, and doesn't go very far.
Yeah.
Fine. Maybe I find a more exciting one here, but these are all shades of the same. Like this guy here, just do him. Made a vector guy. And he says I cut and paste because my fingers didn't do a good job. How about now? Right here, because I didn't go to console. I did. Oh, I didn't. Fine. Yes. Here. Go to here. That's it. Okay. How about now? There it goes. Okay. So the return says I am returning a pointer to a vector 2D. That's the black line from return up to the new vector 2D. And I'm returning a memory of .x. So we have perfect aliasing or equivalence class aliasing in simple, same as Java's aliasing, which says it's a .x stored with a value 1, and there's some prior stuff, and I don't have a store people optimization. So the two stores in the hard left could fold, they don't. Then I'm returning the Y state, and the Y state is the fee $3. That is .y equals, and it's a couple different things. And again, there's some more stores I could clean up, and I didn't. So I could go through and do a store optimization. That has a high payoff. There are a lot of people that do store optimizations and are useful.
Can you show the original source program so I can orient it with where the docx is?
Yeah, right. Okay, so here's the original. Make a vector 2D.
Okay.
And I'm going to return it down here as a return v. So I'm returning a new.
Okay.
And I set x to 1, v.x is 1, and I set our v.y to either 2 or 3. So there's a phi function starting 2 or 3.
That's the dot y. Okay.
Yeah. So another thing to note here is there's all these initializing stores to 0. If you see there's a £0 up there, .x equals £0. So the simple semantics are you don't get uninitialized memory. So I put a £0. Now I didn't optimize it away. And that's a store after store optimization. It's very cheap. It's very easy. It works great. It would get rid of the initializing 0 store.
When you say uninitialized, it cannot be null. So it cannot be represented by a null source program or something.
Well, I'm not let you write a source program that has an uninitialized value.
Okay.
The compiler semantics, the type system can recognize and support that. So I could say the new vector makes an initial memory state for X and Y fields that is unknown or uninitialized. And the compiler, the type system could totally represent that.
Yeah.
And I could even track that and say you're returning an uninitialized, so you have an error, and then I would blow up on you and say, no, you can't do that. You got to initialize this thing. Or I can just put it to 0 and then optimize it away because it cost me nothing or next to nothing, microseconds to nanoseconds to make it a 0 and initialize it away. So I don't make it an error. I just say it's just a 0 and it cost me nothing.
Okay.
And then you don't have to think about uninitialized memory. That's the Java design plan, which I like. And like I said, it's super cheap, so you don't care. All right.
Cool.
We do a store up to store live update coding hack, or it can be done. It can be done. Let's see if anyone else wants to say something here. Yeah. So whenever I do these demos, it always ends like this.
No, I have one question for you.
Yeah.
No, it's
so we talked about pushing data ops down through feed nodes.
Yes.
So I'm curious what the rules are around that. So a couple things, like, is it basically anytime you have the same node type, you can move it down through and then just copy all, like basically turn all the inputs into fees, or is it limited to only certain types of nodes? Or
so where is this guy? Here, hold down a common data op, one less op in the world. One more fee, but fees do not make cut. That's the comments.
Yeah.
So the rule here is I've limited it to number of ins of 3, which is 1 and 2, and 0 is for control. Which is not necessary. You could have ops with more. This is the op has inputs.
Right. It
The
could
op
all
is a
like
2-input.
you'd miss unary ops here, right?
I could pull unary ops down. I could pull more things down. This is an unnecessary restriction. It doesn't happen very much in simple. It wouldn't require very much code to handle. You get 1 fee for every input. So if I had a special magic weird op that had 3 or 5 inputs, I'd have to have 3 or 5 fees. Okay. So I fixed it to 2 so I didn't have to write a for loop. And it has no control. So that's in 0 is null.
Yeah.
That was, I'm not doing things that have guarding tests that need a guard test. Okay. I'm not doing control flow because if I look at the inputs on fees, sometimes I find regions in some places. So whatever.
Yeah.
And whatever same op is, we'll have to go look up same op here. Having done that, the transform is here. So let's go look up same op. So same op says, walk from 2 and on, look at number 1's get class and make sure it's equal to the rest. So same opcode.
Okay.
Now, if your opcode had other equivalence constraints in it that I'm not picking up here, I would be broken. Suppose I had an opcode that had an internal hidden constant like a con node does. The con node's constant is whatever. So I have a con of 7 and a con of 8. Well, I can't declare them same op. So this test would fail for con nodes. Now, in the idealized graph, almost nothing else has hidden internal state. Projections land under the control scenario. They don't hit here. And then you don't merge them at fees anyhow.
Yeah, in simple, every op like add, multiply, everything, they're separate classes.
Yes. And so if they were not, I would have to do some other test here. And I could do a test like everyone has a label. If I go up to mul node, he's got this string label.
Yeah.
I could just say, hey, you got the same label or you don't. There's some constraint that says you're the same thing.
Yeah.
But that fee node rule, that works for any op that has 1 to n inputs. If I made a for loop here, has some inputs. It's not control based. All the ops the same for everybody. It's not a control flow. Yeah. Going to haul it down. Now we can be careful with like stores and loads, but they actually work. So I have a load here and a load here to produce a value. I can bring the loads down, but I'm going to stretch the lifetime of the memory for the loads. So I have stores up here and stores up here and loads up here and loads up here, and the stores come after the load and stomp the memory, and I pull the loads down. I get a weird memory state. So that transformation will work if I also pull the stores down. So to do this for memory state, I'm going to need a cutout that says either don't do it or add some more smarts.
Yeah. I found in the last one that I did that if I did anything with stores or anything which is changing a memory or an IO type state, I had to be careful that it didn't have any other users. And if it had
That's
more
my normal
users,
cutout. Yes, exactly. That's my normal cutout. You have one user of the produces the new state of memory, but you don't have a secret load user or something. Yeah, there's an easy cutout test.
Yeah.
It's not like you need dominators or anything weird or big hunts. No, it's a 1 step removed, but you need the test. Yeah.
Yeah.
And then, and in case for the loads here, it would be you go to the memory input and the loads have 2 loads and 2 arms. If they're this merging at a fee, I want to fold them together. They come from the same base pointer, so their inputs are going to be the same. Are they going to be merged? I guess they don't have to come from the same base pointer. But yeah, you're right. Okay, I have 2 loads. I look at their memory states. Those memory states need to have, they will have another memory state definer later on. It has to be after the fee. And for that one, if it's at the fee, then there would be a fee there that would use it. And if it's before the fee and has another user, you'll have another memory state fee there. So there's a thing you can look for memory. I think you have to look for a memory fee and says his inputs go further up. Parallel to the load, the fee that I'm doing the fee of the 2 loads, I would look for a memory fee and see that his inputs don't conflict with the loads. So there's a cutout test that's 1 step removed. It's pretty cheap, but it has to happen.
And then the other question that I have is, I never actually implemented the moving data through fees or moving ops through fees. And somehow the reason I didn't do it is because I always pictured it somehow going in the other direction. And I'm wondering if you ever have it going in the other direction.
I do.
You do.
Add does that all the time.
So how do you decide which direction to go?
Those rules you see out here, they complement each other because each one individually reduces some property.
So sometimes you've got you've got ops where you've got say an add in both branches, and you're not moving it down, you're moving it actually up to before the branch.
So I've parked at an op that says I have an add. One of his inputs is a fee of a bunch of constants. And I have another add of a constant. So the outermost in the comment here, the outermost add, I put the cursor on it. It's a con on one side. On the left, he's got an add of something else and a fee of constants. So I'm going to push the bottom add up through the fee, and I'm going to get it with an add of a pair of constants and the X plus below the fee. So I'm going to rotate the fee up, and you'll get the X plus becomes the bottom replacement add. And the original add I started with effectively gets cloned. I get one add here and one add on the other guy. So you get two adds for one, but they're known constants.
It's the later add that's getting cloned, right? The X plus is not. Yeah,
the X plus is not getting cloned. The later add is getting cloned. And it's getting cloned in a way that, although I make adds for it, the adds are going to fold up because they're con plus con. So after the add of con plus con finishes, I just have a constant. And then I've ultimately removed an add in the world.
Yeah, so you'll have a fee of two different constants in the end.
Yes. And I'm willing to have more constants in the world. So I'll let the constant count go up in exchange for some other count going on. So I'm basically replacing an add with a constant.
So is this strictly for constants? It's the only time you do it?
Yeah, there has to be a profit metric here. And the profit metric for me is I get this. So this is a fairly complicated comment, doing a fairly complicated thing. But in the end, he comes down here and he says, right-hand side is a constant or a fee of constants. Left-hand side is a constant or whatever. The other guy is a constant or a fee of constants, not this one. This has to be the same. They have to be the same region too. Oh, that's that cut out. This is the recursive version. Oh, I'll do one here for things that are the same class. Oh, then the add of X plus could be an X times or an X minus or an X divide.
Yeah. And do you look up through a stack of fees? Or you do one fee at a time?
I do one at a time because I haven't needed to look through a stack. So you're saying I have multiple control flow merging points and multiple if tests or something. No, these are locally done. Now, C2 got a lot more aggressive about left spline manipulation of address, especially for addressing math. And so I kind of went to a canonicalized form of left spline adds of multiplies, where I replaced multiplies with shifts. And then those would turn into an x86 op that did the whole addressing mode in one instruction kind of thing. So I got a lot more aggressive in C2, and he could look further for profit, but he always had to do a profit check.
Yeah, I'm just thinking that like you could basically have a predicate that's saying fee is some sort of constant fee. I guess that's what you're looking at here.
Yeah, no, this is the can I rotate. You're looking for this kind.
Oh, okay, right. The fee, everything's a constant in the fee. Yeah.
Yeah.
So then, but like you could basically make that recursive. And then you could say, well, constant fee could be two constants, or it could be a fee with a constant fee in it and a constant, for instance.
So the thing to do is to look at the graph after you've had some code gen running for a while.
Yeah.
And see what common looking patterns that you're surprised don't go away.
Right.
So I did things that I know would tackle addressing math right here in simple, and just the first easy cut of it. There's nothing along array addressing math, which gets you the multiply, add, offset thing games. Not happening. But that's all I did because I want to have driving test cases before I just throw down peoples. Otherwise, you do run the risk of having peoples that are not complementary. You get into these cycles where they do and undo each other, and then you're infinitely peopling and shit like that.
I see.
And then you add cutouts to say, well, this or not this or whatever. It gets more and more and more complicated to get a thing. It's much better to see that you have a problem, try to make a canonicalizing version that you can see the monotonicity properties in question. As soon as I got complicated, I started adding these, not here, an add node. I started adding these comments to see what it is I'm trying to accomplish because it got too complicated to be canonical. I mean, to avoid these cycles. And so there are asserts that say things like, I've run 10,000 iterations in the people guy, maybe I'm stuck in a cycle, right? So you have to engineer your way to like adding more and more complicated peeps. A lot of the simple ones are just obviously simple. Multiply can become a shift. Multiply by powers of 4 come shifts, and adds of 0, multiply of 1, and all these kind of things. You can fold those up easy. But as soon as you start getting a little more complicated, you have to do a little more thinking that you're actually monotonic. So this was my big goal. The next 5 peeps in a row all support that goal. And they do a thing that one by one says, move non-adds to the right and do some more stuff. And now I have this comment that says, hey, I've extracted but never at the end. I've removed a case. And then I do some more things. And then I have another case, but never these 2 cases. But I have these other cases. And then I do something else. And now I see this. So now I'm in left spline form.
Yeah.
But I had to think my way there, or like I said, you get doing and undoing transformations here.
Yeah.
They fight each other.
The move non-adds to the right-hand side, by the way, is that a step towards canonicalization, or is that just something you're doing specifically for the benefit of these peepholes?
Both simultaneously. It is canonicalization. They trigger all these other peepholes. And other people's trigger because you've done splines or whatever. And the reason to go to a spline form is primarily so all your constants in your addressing math become adjacent and fold up.
Yeah. And do you have another canonicalization step where you put otherwise equivalent but like non-constant nodes in a fixed order, like order them by ID or something?
Yeah. So spine comp compares 2 off spine nodes and decides what order they should be in. So going back up here, the comments, do we rotate X plus high plus low into X plus low plus high? So I have 2 adds, high and low, they have 2 offs. Do I swap them like this in the spine?
Yeah.
What are the rules? Okay, this is the sort compare. This is the sorting rule. And the sorting rule says constants go one way. Off fees with dead control are going to die. Off fees with all constants want to go a certain way. Off fees of more fee things want to go the other way. And then, I give up. I don't have anything smart. Order them so that value numbering can pick them up. So if you have A plus X plus Y and A plus Y plus X, I'll reorder and you'll get X plus Y twice, and then I'll fold them up. And then you'll have A plus X plus Y, and that'll fold up.
Yeah. Yeah, okay.
So that's add is like the worst.
Why is the that canonicalization step required above if you've got this sort of more general one? Like, why do you need it separate?
Like constants here?
Well, you've got this whole set of rules
for
canonical order, but then like somewhere else you've got, flip them around if one's an add node and the other's not.
Well, I get into spine comp once I have a spine form. So here I've worked my way along to get into a spine. So I first try to shuffle things. I have an add of an add of adds of adds. And after I screw around a while with these other guys, I get a long left spine, add. plus, what are these other things are. Now I have a long left-hand spline tree with things poking out. Each of these I sort with spline comp with effectively a bubble sort. And, you know, it's small size of things, so I don't care it's a bubble sort. I effectively bubble sort them. And then I get all the constants adjacent. I say, oh, add of constant with add of constant. Oh, fold it up. Add of a mole of a constant. Oh, do something different. Add of a oh, do something different. And like I said, C2 got a lot more aggressive here. But effectively, you force a balanced binary tree of adds into a left spline, and then you sort. That's what's going on here.
Yeah. Okay. Makes sense.
And it's locally correct after every transformation, and also monotonic headed for the desired form to optimize. Okay.
Cool. That was heavier than usual.
There you go.
And it was interesting. I was able to follow
along.
Which, yeah.
Good. I saw you yawning there. You're gonna be on YouTube yawning away.
No. Because it's getting late and I'm tired.
Yeah.
I don't know about anyone else, but I always yawn when I'm learning stuff.
I do too. I have a timer in my head, it runs out, and then I'm like, oh, my brain's getting tired, and then I start yawning a lot.
No, it's just like,
or maybe
you need some oxygen to fix memories.
Yeah, that's what Sarah. I think you need the oxygen, so that's you.
Yeah. Yeah.
I guess so. Yeah.
And maybe a 5-minute, 10-minute break where you get up and walk around. The other thing is like a little break. Somebody asks a question and people kind of get out of the zone where they're staring and they start thinking again, and then they start asking more questions and the questions cascade. And it's very helpful for everyone else to stop and let people ask or make them ask.
Yeah.
Also, I get that using this to represent the type system, it's adds another layer of complexity. So we are talking about types and stuff, but you always need to represent them in this framework. And that's, I wasn't realized until now that you have another layer to think about how to represent them in this framework.
The type layers?
Yeah.
So every compiler has a type layer. And this one, the only thing special about the type layer really over what other people do is like you get into the memory types. Everything else is like very plain Jane typing. I add a rule that says your type system has these monotonicity properties, but so does every other compiler on the planet. They just don't talk about it so explicitly. It's because you need them to run these like constant propagation. Conditional constant propagation, you have to have certain rules or it doesn't terminate. Okay, the rules aren't hard and everyone does it and not everyone talks about it. Although if you take a class online, I've looked at a bunch of classes online, not a bunch, 4 or 5 classes online, they all touch on it. You need these monotonicity properties and they're really simple for the simple lattices and no one cares. So having said that, I can throw into the same type system control. It looks just like anything else. It's totally part of the lattice. It's free. Then I have a canonical form. Every node has a type, and I can have int types and I have control types. And we lived with that in simple up to like chapter 9 or 10. Then we added pointer types, and then memory types. And so you get a few more types now. And now memory got weird, and it's not really weird. It's just you had to add the little thinking, and that was we have this equivalence aliasing, and therefore the memory types and the pointer types mention the alias.
How come?
You seem to have a memory type, but not an IO device type.
Yeah, simple doesn't, but it could, and it would if we started doing IO. So C2 has an IO device type.
Does AA have an IO device type?
I haven't got that point, but it will. Yeah. This is like a very, so I hear you, Theodore. It's a very simple thing to add. And you have to thread it through function calls that you don't know what they do. So it's easy to add, easy to deal with, but you have to do it. All right, Theodore.
Let me say, I forgot. How how complicated would be to track ownership in the systems? What would you need to
right.
add to track ownership? So like
Right.
to get closer to linear types.
Right. I think it can be done, but it'd have to be expressed in the lattice as a form of, whatever ownership means. And then the transfer functions on loads and stores that move pointers around would change their types according to whether they were, copying a pointer or moving it or destroying it or whatever. That's pretty straightforward as well. And so I think you could do it. Having said that, I haven't done it. I think it could be done. And you could do it in simple. So I could come through and say, that simple program that just had a new bar that was dead.
So yeah, it's not really that complicated. You need to track where the assignments are. So that's the ownerships. That's what. Yeah, that's in theory it shouldn't be that complicated. But do you need? Yeah. Do you need more stuff to represent that? So, or you can you have the low level mechanics to do that. So, or you need something else.
I think that we need a few things, but not too many and not too difficult. I think you need a notion of a pointer that has some set of known users. And in the type system, that might be a count that was a constant from the type system's point of view. The count of users is always known to be a fixed known cost, or I'm borrowed, I don't delete this, somebody else will. Right? There's an unknown users, I'm not the guy deleting. The assignment guy puts a drop in there of the old thing. So you do an assignment, he sticks a drop, the parser just dumbly sticks a drop in. So you have a drop node. The drop node looks at his input. If his input type is I'm the last thing, he's going to actually be a drop. If his input type is I'm some borrowed thing or whatever, I'm just going to lower the count on it, or I'm going to do nothing. And then the drop becomes a no op and disappears. Maybe he sticks in the graph as a counter because he's counting down to 0. And he doesn't generate any code. He's just being tracked by the IR as one more, one less until you go to 0. Yeah. So I think this can be done. I mean, what
so can you track? Can you both track the when can you reuse the memory or something? So along with the ownership.
No. Yes, but that comes out like kind of out of the runtime, and then a later stage in the optimizer might do something more explicit. Like from an idealized graph point of view, I'd say I had some memory, I used it, I'm done with it now. Okay.
So it can be reused. So that's
I heard you. Right. Yeah. So there's a couple ways to go here. And one is to say, I threw it on a linked list, I pulled it off. I did a fucking malloc and a free, right? So I'm reusing it because I pulled it up the free list. I did a malloc and a free and a malloc and a free. And then, the linear logic told me I got in the right order and there's no other smarts involved. Then there's a version that says, I'm going to do a little more smarts. I'm going to say, I have a whole series of these mallocs and frees in some contained area. I'm going to region allocate them and then poke them directly with my users. And so at runtime, we're just going in and out of the same bulk region. So I think the answer is yes. I wouldn't do it. It won't come out directly out of the sea of nodes per se, but I would run a path like I do the loop ops thing. I would do a separate pass where towards the end of optimization, when I know my lifetimes are fixed and things are what they are, I can't get rid of them anymore. I can't just throw them away. Then I'd start to say, can I batch a bunch of these things up and reuse in place? I'm doing bin packing at this point.
Yeah.
A lifetime starts and ends, starts and ends, starts and ends. You have a bunch of them, you bin pack.
Yeah.
Okay.
Because you discover something that maybe you discover that same request HTTP then frees all this memory so it can be reused all along.
I put a single entry, single exit lifetime region on the memory.
Yeah, that's cool.
And then there's a bulk batch. Yeah. Okay. I think we're talking the same thing.
Yeah.
Yeah, I've thought about the linear logic side a while, and I haven't done it, and I want to, and I think it makes sense. I think it should work.
I think so.
So you gotta find out what you
did. Did you have any thoughts on running sea of nodes, then when it's all done, passing it to LLVM?
No, although you know, I'm well, you're welcome to make that experiment. It's like, I wouldn't pass the output of LLVM back into LLVM again. You do all the things that LLVM does, and then you get down to the back and you leave it at some IR that's not quite yet machine code. Then you run it through them again. Well, after a while, these passes don't do anything because you've done it already. So now is C of
So the only
nodes.
thing close to that I've seen was something that essentially generated ARM-looking code and then handed that to LLVM to be like, can you pick reasonable x86 instructions? Because you know a lot more about x86 as a CPU than I do. And
Oh, I see. So somebody converting ARM to x86. Yeah, that's a binary translator. Yeah, that makes sense. I've seen other binary translation projects, and some of them went through LLVM. In this
I
case,
figure
But can you do,
I figure it would be slow, but I just figured that maybe they did a bunch of optimizations you never had time to do.
simple doesn't have a lot of core like loopy optimizations in it, but C2 does, and they're really quick, and they do most of the kinds of things that you would expect out of LLVM. So I would predict not much directly. Now, Arthur's not here, and he's usually on. He is getting some mileage out, but he doesn't start by coming out of C of nodes. He starts by saying, I'm adding all the profile data that C2 has to LLVM. And then you have to add some Java specific optimization. I shouldn't talk about this. I should let Arthur do it. And he's getting some mileage.
Next
He's
week.
claiming he's beating C2 not by buckets and loads, but by some, but on a large scale. You know, not like, hey, I targeted just the benchmarks and I got some wins on just the benchmarks. No, he's doing something real. And I can believe that. Like I said, I stopped at C2 at that time because that was the biggest bang for the buck, and I got nearly everything. And in the last 20 years, a bunch of cool other things have happened, and how people write Java code has changed, and there's more, more meat on the table to be picked on.
the biggest difference from when you were working on it and now is it's using the SIMD instructions when it's unrolling loops, which I don't think you were doing.
I did the SIMD instructions just before I left. That was the last big thing to be done. And it just the early versions, SSE versions, not the AVX that came after. So I assume that those are now fairly reliably being generated, but I don't know. I guess I've seen people talk about it, so there they are.
Because those can be big wins. There's stuff that goes twice or three times as fast when you start doing these 8-way.
Yeah.
but you need a good support for that, even at the level of the language, because you cannot hope that they happen. You have to be sure. So
No,
you have to rely on it.
No. C2 is just picking them straight out of the Java code.
Hmm.
So the loop optimizations, they start by canonicalizing and make sure you have pretty nested loops with counts, and then they order according to frequency, so the proper nesting's on the inside. Then I will do cache line alignment for some of the guys by adding a few iterations to the end or beginning to get you aligned. And then I'll unroll on cache line alignment boundaries. Okay, and now, once I enroll by 4, it's straight up to 4-pack you into SIMD ops.
Yeah, but my point is that you need to guarantee that will always happen. So the code written in that way should get some guarantees.
It depends who you are. If you're a high-speed trader, you really want the guarantee that it's going to be the same time every time. If you're Twitter, you just want to play a bunch of best effort stuff and hope you win on average.
Exactly. And the code that the Java is given may have very short trip counts, and it makes no sense to SIMD. It may have loops that are like one or more of the arrays involved are misaligned relative to each other. Like I can only align one loop, one cache line align one of the arrays. The other arrays either cache line align or they don't according to their relative offsets. I can't ask the garbage collector to move them. So they are or they are not, and then that dictates what I can and can't do. And those all cutouts all happen in the code. So the loop has to be big enough to run through all your safety checks and your profit checks. But then you kind of reliably get a, SIMD 4 op, at least on one of the arrays. And you're like, it has to happen. It does, except that it will if you have a long running array, long running loop where the count of arrays that you're writing to is limited. If you're writing to one array, it'll be aligned. If the other arrays are misaligned relative to that guy, you may or may not get a SIMD op, and I'm kind of like wedged there. That's what the Java semantic lets me have.
That reminds me of a funny thing I ran across once where we had these arrays that were slow, but if they were slightly larger arrays, if as the vector grew, eventually it got to the point where the underlying array was sized large enough that the compiler decided it was worth cache line aligning the array because the array had become larger.
Yes.
And it ended up being these things that like it would run with 1,000,000 elements twice as fast as it ran with 100,000 elements.
Oh
That's
my
why
God.
that's what
Okay.
I'm talking about. You need some guarantees even
So
from the
it got 8
programming
times
language.
faster, but it only got 8 times faster
Okay,
once the
wait.
vector was big enough that the array that was underlying it got cache aligned.
Yeah, that's not, I bet you that's not cache line. I bet you the GC said the array got big enough. I'm going to move you to old gen big object space where I will TLB page you align you. And you got 4K aligned, not cache aligned.
Hmm.
And
So-
everyone who's big, so all your big arrays all got 4K aligned. Therefore, they all had mutual self-alignment. So the alignment check comes in and says, make the first guy aligned. Oh, check the rest. Oh, they're all aligned to the same thing. Oh, I can use the hot loop. I can use the fast loop.
This is what I'm talking about. You always write your code so tricky that the compiler should assume it, but you cannot guarantee.
This isn't the compiler per se. This is when you say in Java new array, it doesn't get more alignment than the minimum necessary. So 8 or 16. You know, if it's a small thing, it'll be 4 because you just need a length. If it's a car array, if it's an array of longs or doubles, you got your pointers and big guy, you got your 8 or your 16. Okay.
How about some support, but like a size hint?
Yes. You would need a support. I think in unsafe there's support for forcing alignment.
Yeah.
Yeah.
I
think you can
think that
ask for a new array at a forced alignment. You can also use unsafe to make an oversized array at the Java level and pick the array walking to you manually pad it yourself. You can ask, give me a giant array that's too big. Ask the padding, shift by the padding amount to get the alignment I'm looking for, run my iterations at this padding. Then the C2 for loops start by saying, iterate till the left-hand side is padded correctly, check the right. Oh, the right's also padded, I can do the good stuff. So you could do it manually yourself, but I think you have to dip into unsafe.
Yeah, that's one of the things I've gone back and forth on is sometimes it's really nice to be able to say new vector, but by the way, start with this capacity so that you're not constantly making new arrays and copying everything over. But also most developers, when you give them that tool, use it wrong.
I think some of the collections has a hint size.
It's not the hint size, you want hint alignment.
Hint alignment.
So the doubling trick is generally not very expensive. You're touching that array anyhow. The most it costs you is double the clock counts for like reading or writing or whatever. It's not very expensive. You already did a bunch of work to fill it with something. You added 10 more clocks per thing to fill out of however many hundred it took you to compute your fill value. But
so I think what matters is that I got 4K aligned, not that what matters is that I didn't do the copies for the first 6 growths.
You want to say, give me the 4K alignment. That will, by the way, also save you bogus TLB misses, and you're less likely to thrash the TLB. And one of the other things going with the really big page alignment guys at some JVMs, some allocation scheme was they went to the 2 meg or the big pages. And the TLB and the JVM all talked to each other and said, use a big page here. And then you had extra TLB entries for everything else, and you quit thrashing TLBs because you only needed 1 for the fucking array.
So isn't the simple answer here then to just say, okay, I've got some data sets with 100,000 elements or whatever. I'm just going to make a sort of arena to work in that's 1 million elements or whatever size I'm sure I'm going to get into the right alignment, and then just use a subset of it. It doesn't really matter because memory is pretty cheap. So
that was what I said.
Yeah. Okay.
Make it oversized and force alignment.
But you don't need unsafe or anything for that.
You don't have an alignment. You make a large array. What is its alignment? The JVM makes no promises.
Okay, well, I guess I understood that if you go big enough, then you just automatically go into a certain space, which will have
There's no guarantee. But if you, and it doesn't immediately go into big object space. But some point, but you could try that as a technique that's probably good, reliable across a bunch of instances of versions of the JVM. Make an oversized array and have them align.
Mm-hmm.
And you get this other funny thing. You'll have a mark and a class word and a length in the front. And now what's your alignment? How now, brown cow? What's your alignment now? Well, it's 4K to the start of the object. Minus 8 bytes for the mark, minus 8 for the class, minus 4 for the length, pad it up. Okay, I'll add some more padding. I'll do longs plus 1, blah, blah, blah. Oh, look, I'm on compressed pointers. It's 4 plus 4 plus 4, and my alignment's different. So you kind of want to get an alignment.
The compressed pointers throw all bits.
Yeah, right. Yeah. And is the JVM doing some bizarre mix? I guess they don't do bizarre mixed mode, some compressed, some not. I think that would be disaster.
Yeah, it's running to
But I think a
mode.
lot of that goes back to I want this syntax to be available, but almost intentionally clumsy, to be like, most developers should not be using this most of the time.
Yeah.
Only put it in your hot loops where you know it matters.
New array list of extra parameter that says it's going to be big, pre-align, and I'm going to vector loop giant things over it. I'm going to run big loops over a big array, pre-align for that.
You know, if I can avoid writing in C++ because I can annotate a handful of important things in hot loops.
Yeah.
And the rest of my code can be written in a much more garbage collected friendly Java style.
I think if you look at the billion row challenge, you'll see a bunch of stuff that's that way. It's very close to pure Java. But they get okay, so they're not doing alignment. They're doing fucking character parsing, so they don't have to play the alignment game. You do have to break up
you
the
sort of
giant
did that with
arrays.
the way you used mmap.
Yeah, you have to mmap. You're using mmap directly, which whatever alignment that gives you. But that's because you're reading the giant ass file from disk, which maybe you are. I don't know. Yeah, there's something there. Go look for unsafe alignment things. I think they're there. There's your bad syntax you hate to use. You have to say, make me a new instance of unsafe. I have to say unsafe dot blah, 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 alignment, blah, blah, blah. I have to look up the word API. I get told by everyone on the planet, don't do it, it's bad. Of course, you double your speed. You're like, what the fuck, dude? I guess if you look at, Billion Row Challenge, a lot of folks grabbed unsafe. And oh, look, people got 70 times faster than an obvious naive implementation. Just like, there's something there, guy.
But once you've done it, you come to expect it. So you start to move and write the code with these premises. So
been deprecated for 20 years. It's like they can't get rid of it.
Yeah. So no.
They should remove the fucking required to be printed deprecated. Because now in my build scripts, I go through and say, build, if you didn't get a compile error, now filter out the fucking unsafe warning that you can't get away from. And then, there was no output, so hey, the build was good. And just like, why did you make me write a fucking grep after Java to get rid of this thing? Like, geez, folks, get a clue.
Yeah, the thing that I trip over is, so you can often get major performance improvements by doing these sort of hard-coded, I need to align this thing, or I'm going to make a tiny resource pool. I'm going to make an array of 4 of these things, and that's going to be my arena, and I'm just going to keep overwriting them. I have to be careful because I've introduced the possibility of a use after free bug if I don't do it correctly.
Right, but you got these giant speedups, yes.
And I've been in multiple projects where hundreds of these things got added over time that were these little speed up tricks.
Right, sure.
And eventually they get so out of date that someone goes through and says, I'm just going to remove all of these and let the GC do it. And it does better.
Oh, really?
And then you profile and go, oh, these 4 need to go back in because they were actually the things that are still relevant.
These count.
And it's like, I deleted 100 micro optimizations. I put back 4 and now I'm getting more speed.
Okay.
And I've never found a good way to do that cleanup other than just scan through the code and see if you spot them and remove as many as you can find and then run the profiler.
Somebody
How
has
large? How large was that project?
apparently pretty big.
I don't know how large the entire project was. I think it was like 64,000 lines or something.
Oh, I thought it was going to be like 1 million to 10.
No, it was something that was, so the entire repo is like 10 million. But most of the microservices themselves were fairly small.
Oh.
And a lot of them were these little array math things of, you know, even simple stuff like get all of the people who are following this person. And keeping those index and inverted index aligned with each other. You know, ends up being a lot of chunk through large arrays and check for consistency and fix things that have become inconsistent because it's cheaper to eventually consistent fix things than keep them consistent.
Oh, you're hurting me now. Fine.
It's one of those moments where you're like, if this data set were slightly smaller, we would just put it in SQL and walk away.
Okay.
Cool.
There's things to be
Interesting.
done there. No, I got my hands full. I got too many projects on my table, on my plate.
Also, this is where I put in my plug for CockroachDB, which actually is pretty scalable SQL. And we had a lot of these terrible kludgy hacks that we were able to literally stick in a CockroachDB table and walk away. Anytime you can replace a microservice with a table,
Yeah,
that's a good day.
yeah, okay. Ouch, but sure.
Why is
Alright,
that ouch?
I'm gonna call it, because just the concept of throwing a DB in over a table versus a microservice. I'm like, no.
No, that was a
Eventual
regular occurrence
consistency.
where the team that was maintaining something would leave. And a new person would come in and be like, okay, what is the actual value that this service provides, and drill it all the way down and be like, oh, the data comes in from these places and goes that. Wait a second, this is a table.
Yeah, yes. I get that one. There's some big picture, take a big picture look, and then you can say, draw a circle around this entire region, throw it out. It has one input and one output, table in the middle, done. Fine.
It worked more often than I expected it to.
I call it rip and replace, and it's a common feature when Cliff goes after your code.
The trick with rip and replace is that you can't turn it off.
You mean like put the old code back in?
No, that Twitter needs to stay running. You have to put up your new service and find some way to get them to like mirror for a while to gain confidence in the new one, and then cut over and.
Right, I'm not talking about running code. I'm looking at your static code in front of me, rip and replace. I have a new version. When it passes testing, then it goes in production. Yes.
Yeah. I think it is a underappreciated technique of removing complexity by just being like, wait, this whole section here is super complicated, but it's actually.
Yeah. I've been lately a lot of over engineer would be underestimated. So I've been dumping down the code a lot, and where it needs to be, I spend maybe weeks to introduce something as little as possible. And so, some questions are why this is taking so long, because this is hard work, is my answer.
And again, it's not a condemnation of the people who built the service in the first place, because they started with an ill-defined task, and the task evolved for a while, and they figured out what they needed, and then they simplified the APIs when they actually found stuff. Like often the reason that you can replace a service with a table is because somebody spent years really simplifying that service to be the clearest API in and out on both sides that it could be.
A service that is put into production without clear requirements and a plan is pretty early. You figure this is the case, but there are some pretty common cases that is just an over engineered. So what can happen if we needed that? What can happen if you need that? If you need that? If you need that, and you need something 20 things that you never needed them. So the code just became a huge pile of complicated spaghetti mess. So you can, you just cannot simplify it. You can just scrap it and introduce something simple.
All
So
right.
how do you build up a discipline of simplifying things? Like Cliff always says that he looks at things and does the most obvious thing he can think of, and that turns out to be the simple thing.
So last comment, I caught myself that a lot of the development I do is to a real data. I just build something and try it myself and build upon it and try it myself and try to simplify it. If you can simplify it, step 1, 2 steps back and try to build it again. That's really introduces the complexity when you really need that complexity. So not upfront, and then try to simplify it.
You just said what I was going to say, but my version was going to be a joke. Have no dependencies, rewrite everything yourself.
No. That's the really slow way to get features done.
Do take
Yeah.
So I can, last comment, I can introduce it to some shortcut. So try to isolate that dependencies behind the methods, behind the class, behind the interface. So you just don't deal with them, and when the time comes, then write on your own. But you have to be able to roll forward.
All right. I have to stop at some point or I won't get
Yeah.
my lunch.
So yeah,
And I have things to do this afternoon.
cool stuff. Today was really
Thank you
interesting.
all.
I'm sorry?
Today was really interesting. So
Yep. Thank you. And it was good for me too.
thank you.
All right. Good night and see you next week.
Go.
See ya.